So today we're going to be talking about Chainlink, smart contracts, off-chain data APIs, and we only have 30 minutes, so I'm going to try to breeze through this part so we can get right into some of the truffle bits. So, yeah. So just to give you a quick overview of what we're going to be talking about today, we're going to talk about the smart contract connectivity problem, how Chainlink already supports the growth of DeFi, the DeFi ecosystem. Talk about untapped potential in some of the projects that people can build and have yet to build. And then some tools and resources that you have to build these chain-linked smart contracts. So we're going to be, and at the end, we're actually not going to be using Remix. We're going to be doing a Truffle demo, which makes a lot of sense because this is TruffleCon. But yeah, that's basically the overview. And again, this is meant to be a collaborative session. If any of you have questions, feel free to just, I'm going to be monitoring the chat, drop it in the chat there. I know from the polls, there's a lot of beginner blockchain engineers here. So definitely, there's no stupid questions, 100%. Feel free to ask questions. Happy to answer. This is why I'm here. So I love talking about smart contracts and teaching and building and learning. So, so the smart contract connectivity problem, and really to understand Chainlink and what the purpose of Chainlink is we first need to understand that smart contracts are not able to connect to external data or any off-chain resource on their own. And this is actually a huge limiting factor for smart contract adoption because it means the only thing that we can currently do in a smart contract is token transfers. And for you engineers out there, the question then becomes, okay, well, why does the blockchain just make an API call? That's what every other system does. And this is actually really important. And the simple answer is that blockchain is deterministic, and it needs to be able to validate by all the other blockchain nodes on the chain. So if making API calls is part of this validation, it's part of this consensus protocol, then no node is going to be able to sync up because they're going to get wildly different results, right? If one node calls an API, even an instant later, that API could be updated, it could be changed, and you'll never reach consensus on the chain. So that's why you can't really just make API calls. So, but we still want to be able to interact with the outside world, and we want this data so that our smart contracts can do more interesting things other than just token transfers. So in order to do this, we need what's called an oracle or a blockchain oracle. And a blockchain oracle is any device or entity that interacts with the off-chain world to provide data to these smart contracts. And they report the result of that data on-chain so the blockchain can stay deterministic. And this is really where Chainlink comes in. So there are thousands of APIs out there that are already providing data that people need for their applications. And Chainlink makes it really easy to enable connectivity between those APIs and smart contracts, even if they require authentication. So now you can have your decentralized applications powered by the exact same thing and the exact same reliable APIs that the rest of the world in current web applications are using today. And a single Chainlink oracle is also referred to as a Chainlink node, and I'll be using them a little interchangeably here. So a lot of users today still don't really understand, blockchain. They don't understand sending payments in cryptocurrencies because not universally accepted. So Chainlink can do much more than just get data. It can send data as well, and including sending data to banks or to PayPal or to whatever, right? So Chainlink also makes it possible to send payments based off of on-chain interactions off of on-chain smart contracts. Chainlink uses something called external adapters, and these are really this incredibly customizable, empowering feature because an engineer can come in and they can say, "Hey, Chainlink node, I want you to do this super random task," and they can build it to do it. So it's incredibly customizable. And one of the coolest things about these external adapters is that they're written in whatever language that you want. So that they're set up in a way so that Chainlink can listen to anything that it wants. And it enables Chainlink nodes to not just do literally anything. Sending payments, doing some work automation off chain, doing some processing, getting into an authenticated API or a secure system. These are really the feature that just unlocks the power to do literally anything. And the thing that's also fantastic is if you want to build one, but you don't want to have to become a Solidity pro or a Ethereum pro or a blockchain pro, you don't have to be, because it's written whatever language that you want. So Chainlink enables this incredibly powerful feature to get data and post data. And I want to pause here just really quickly because, and then I know I have limited time. We are literally, as you guys have been saying, we are on the doorstep of this insane revolution, right? DeFi this year exploded. It's at like what, 10 billion, maybe a little bit less than 15 billion right now. And we're at this tipping point of DeFi and decentralized applications and blockchain just racing, and smart contracts being this, proving themselves as the dominant digital form of agreement. So, and it's Chainlink, and it's, these engineers who are building, and it's tools like Truffle that are going to really enable us to push to that next chapter, to push to get to bring this adoption to the next level. And I'm beyond excited. So Justin has been wondering this for a while. Okay, cool. Justin, if you have any questions, feel free to pop in the chat if there's something that you're confused about. Because again, yeah, this is meant to be a collaborative session here. But so that's the basics right there. Chainlink allows anything to happen. So feel free to run over time, no rush. Oh, okay, cool. Great. Then I don't feel as pressed for time. But I do want to get to that, truffle chocolate tasting session at some point. So anyways, so here's where we turn up the heat a little bit, right? So a single centralized oracle becomes this insane point of failure for your smart contract. This is why we create these decentralized oracles and these decentralized networks. If you have a decentralized smart contract, right? If you have a smart contract that's being validated by a group of peers, either, on Ethereum, on Harmony, on Matic, on whatever blockchain, right? And you're getting, the logic is all being decentralized. That's fantastic. That allows, to gives the power back to the people, and all the benefits that decentrality brings. But if you get your data from a centralized entity, you've literally given the keys of your decentrality over to this centralized entity. I can't emphasize this enough. If your data source, if you're relying on a single centralized data source, and that data source goes down, they get bribed, they get hacked, whatever, your smart contract is now worthless. Or worse, it's going to actually cause people financial and possibly other types of traumatic harm. So this is a huge no-no. We never want to have our data being pulled in from a centralized node. So I'm going to speed up a little bit here because I want to get to the Truffle demo. Why am I stressing this point? The reason I'm stressing this point is we've already seen attacks that have lost projects literally millions of dollars, right? Since they were using a centralized oracle, and that oracle was hacked. So Chainlink is designed to be this modular infrastructure so that you can build a decentralized oracle network used to connect smart contracts to any API. You can select as many oracle nodes or Chainlink nodes as you like, and use as many data sources as you like in order to trigger the execution of your smart contract. Then again, Chainlink enables this off-chain payments, these off-chain processes, this off-chain work automation, based off the execution of this smart contract. So if the result of a smart contract says, hey, pay Bob $100 USD, you can utilize Chainlink to send that transaction. So really powerful stuff here. Now, to get you started with DeFi, the Chainlink project has actually gone ahead and found many of the best blockchain node operators on the planet and combined their prowess to build what's called price feeds. These are decentralized on-chain reference points that can be considered source of truth or definitive truth for various currency pairs, like the price of ETH in terms of USD, for example. And here we actually have a visualization of what this looks like. You can see surrounding that one price in the middle, we have all these nodes. Each one is an independent node getting data from a different source, returning and posting this data on chain, and then on chain the decentralized logic is aggregating them to this price. So this is working with the same exact concepts that make blockchain work, right? Because if half these nodes go down, the decentrality of the system carries on in the same way, where blockchains are so secure because they run on the exact same principle. So these price feeds are considered source of truth, can be considered a source of truth for these price feeds. And if a node acts maliciously, then get kicked off the network. And even if they do act maliciously, it won't affect because of the decentrality, because of how many other nodes are reporting, honestly. So William, so you mentioned that you don't need to be an Ethereum or Solidity pro. Say I have a group of individuals that are proficient in different languages. One person uses JavaScript, one person uses Python, one person uses Solidity. Could these individuals be able to collaborate together through Chainlink? Absolutely. 100%. So JavaScript, Python, JavaScript and Python are two of the most popular languages for external adapters. If you want to do a quick Google search, look up Python template external adapter. You'll find a repo that does exactly that. It's a Python external adapter. Same thing with JavaScript, actually. JavaScript, Chainlink external adapter, GitHub. You'll get that repo, and it has an example of using an external adapter. And you'll see there's no Solidity code in there. It's all Python. It's all JavaScript. And again, it's because Chainlink is more than just it's more than just a token. It's a way to interact, to connect the blockchain with the real world. And that's a fantastic question. I guess it works with other blockchain networks. Yeah, good question. Chainlink is blockchain agnostic. So any chain that has an integration set up, and anybody can set up an integration. I won't be talking about how to do that in this demo, but you can see some of our other videos, like we did one with Conflux earlier today, actually, that you can check out, that talks exactly about how that actually works. Yeah, of course, absolutely, William. But we got another 15 minutes left, man. Anyways, so to support the growth of DeFi, the Chainlink and the price feeds are already being used by a ton of the top projects in DeFi, including synthetic assets, lending, borrowing, trading, asset management. And here's a snapshot of DeFi Pulse from maybe a month ago, and that site changes hourly, so it's probably different at this point. Oh yeah, no, it ends at 8:10, so we have another 15 minutes. Don't worry. What was I saying? So yeah, this is a snapshot of DeFi Pulse from about a month ago. DeFi is constantly it had this huge push today, or excuse me, this quarter and last quarter, because a lot of these projects were able to not have to worry about oracles, know that the pricing data that they got was reliable, and they were able to build these insane protocols because they had reliable decentralized pricing data. And here's a snapshot of the top 5 projects from, like I said, about maybe a month ago. It's probably different now. And Aave, Synthetics, Finance are all Chainlink users. And you can see that these protocols are securing literally billions of dollars. We have Finance at, 800 million, Synthetics 800 million, and then Aave 1.5 billion, right? So the amount of money that the price feeds is helping secure proves its power, its security, and its reliability, and it's really the standard for DeFi data. Check questions real quick. Okay, cool. So I'm going to blow through this kind of quickly. Synthetics, Loop Ring Set Protocol, a couple other just fantastic projects that are using this pricing data in order to stay up and reliable. I won't go into this in the demo, but getting random numbers, for those of you engineers out there, that in deterministic systems, getting random number is basically impossible. So Chainlink has also recently come out with Chainlink VRF, which allows you to get verifiably, provably random numbers. And this is also just another one of these insane crypto magic things that I let the super smart PhDs and researchers kind of figure out. But it allows us to get provably random, provably fair random contracts on our blockchains, which can power things like lotteries, random medical sampling or random sampling, drafting, or even like stat generation for Dungeons and Dragons characters. It can be literally used for anything. This is another project, we're seeing a ton of adoption pop up. Pulled together Avagochis. I wish I had the list in front of me, but again, we're seeing more and more adoption with getting these random numbers. So So that I have time to get to the Truffle demo, I'm going to rip through this. So for those of you who are kind of new to this space, there's so many projects that have yet to be built, and there are so many ideas that have yet to be had. Literally, creativity is your only stopper here. And even the ones that have been made, maybe you say, hey, I could do that better, right? Because they're really, being a smart contract engineer, being in the Chainlink community, being, one of the people who builds with Truffle, you are kind of among the few. There's not a lot of Solidity engineers, but smart contract engineers, but the ones that are, here, they're building really cool stuff. They're building awesome stuff. The community is massive. There's a ton of Discords where people can collect and talk about ideas and share ideas and get together, and everyone's really nice. I'm talking really fast, so I can speed through this. So Decentralized Finance, we haven't even hit anywhere close to someone really loves chocolate. We haven't hit anywhere close to the market cap on traditional finance. So there's so many projects left to be built here. Fantasy sports or any game in general, the VRF has made this even more approachable and even easier to do. Tokenized assets, and in insurance, this is kind of the one that I like to fall back to because of how powerful the example is. Let's say, for example, you're a farmer, right? And you have an insurance policy, you have an insurance company, and they go, yeah, sure. When the bad weather hits, we'll bail you out. These guys are incentivized to not pay you out. They're incentivized to find the loophole because they are the policy holder, right? They hold your policy. They are the ones who give the money out. They have kind of this control over you, and they're financially incentivized to find the loophole. Oh, you have a pre-existing condition. Oh, we don't cover that exact specific storm. And we've seen it, unfortunately, we've seen it happen. And obviously, you can take these people to court and stuff, but if you're sitting in court 6 months to a year, you've already lost big time. So this is kind of just a preach to smart contracts in general. Smart contracts really are tackling this problem of trust and really are this superior form of digital agreement. And with getting reliable decentralized data into your smart contracts, for example, the weather, you don't have to trust that the insurance company is going to do the right thing, right? Because the right thing is infrastructural with Chainlink. So with that being said, there's a ton of fantastic things. Let's go into a demo of using Truffle. Hopefully you guys can see this okay. It looks like you can see it okay. Let me make it wider, I guess. Not too wide though. Zoom in a little bit here. So hopefully at this point, some of you are a little bit familiar with Truffle, how it works. We're gonna close this out. CD code. Yeah, so hopefully some of you guys are a little bit familiar with how Truffle works. How many engineers are here? Or just kind of curious in the chat, how many engineers are, or +1? Okay, cool. Justin, excellent. +1. Okay, cool. +1. Okay, cool. All right, great. We have a lot of engineers. Oh, I love it. So we have a lot of engineers here. I'm hoping that some of you are at least a little bit familiar with Truffle. But I'll go over a couple of the basic -1. I made an Excel formula once. I have 10 minutes. Okay. So this is, so we're going to go through a Truffle project that uses Chainlink, a really, really simple one. But just for those of you who are like, oh, like I kind of want like a kicking off point, a starting off point, a really easy way to start it off is using a Truffle box. So actually, you need to install Truffle. I think it's npm install. I think it's just this. I'd have to check the docs, but once you get Truffle installed, you can do what's called a Truffle box. You can do Truffle unbox smart contract kit /box, and this will kick off a download of basically this repo. I've already done it, so I'm not going to do it again here. But it'll download this repo, and here's basically what you'll get. You'll get a really simple but really effective setup for your Truffle and your smart contract dApp. So you'll get your contracts, and then I'll go over this simple contract in a second. You get your migrations, which is how you deploy to whatever blockchain you're working with. The node modules, which obviously is JavaScript. Your scripts, which we'll go over in a second, and tests, which are really important to make sure you're going good. And cool, no questions. Okay, great. So just to kind of quickly go over this contract here. So this is a bit. Hopefully you guys can see everything here. This is a bit. We made this really verbose so that anybody can come in here. They can read. They can understand exactly what's going on. So the main function that we're going to be looking at is this create request to function. So basically what this does is we give it a ton of parameters, and we do what's called, we make a Chainlink request. So we have this send Chainlink request to function, which sends a Chainlink request to an Oracle, and then it's going to respond with this fulfill request. So it's going to respond with the data. So something that's interesting to understand here is that when we create a request, we choose the Oracle with this address Oracle here. We choose the Oracle address. We choose the job ID, and this is important for getting the correct return type. The jobs also specify, what type of parameters they accept, what type of things they do. So we're going to choose the Oracle. We're going to choose what we want that Oracle to do, and again, the Oracle is the Chainlink node. We're going to send it we're going to send it the link or the Oracle gas. In the same sense, it costs Ethereum gas to make a transaction. It costs Oracle gas to work with oracles. We're going to send the URL. This is going to be the API call that we want to make, and then we're going to give it a path. The path is basically we walk down the JSON to get to it, and I'll show you guys again what this kind of means. And then we do a multiplication of the data that we get, because Solidity doesn't work great with decimals. So and all of this is in the Chainlink documentation. So can I swap windows? Not easily, can I? Brave tab. So all this is here in this Chainlink documentation. It even has like a click to remix to do it. Everything you need to know is in here. And if it's not, or if you get lost, or if you get confused, there's links to the Discord, hopefully everywhere. You can jump in the Discord, join the community, and ask away. So let me share screen again here. Question from two questions here. The job here refers to what? Like the service that this node provides? Yes. So let me show you a window. That's a really good question, actually. I should just show all of Brave, right? Yes, exactly. So we're gonna do two things. We're gonna maybe I should show my whole window so I can stop flipping back and forth. No, I'm not gonna do that. It's glitching for some reason. It's the sharing is making it be confused. Try that again. Sorry about that, guys. Yeah, awesome question. So you're saying, okay, what is the job, and what is this? What is this? What are you talking about? This Oracle thing, Patrick? Come on, talk to me. So what we're doing is exactly this. So here's an example of an Oracle. This is an independent node operator, and this is market.link. It's a node listing service. It shows you different nodes. There's a ton of information on it here. This is the Oracle address. So in our example, this is an example of someone we would the Oracle we would say, hey, we want to send it to this address, and we're on mainnet, so this is the mainnet address. Now we can look at the jobs, and as you can see, the jobs do different things. So this is this job here. We can go through like the task list, which shows all the different tasks that it does. So a job consists of all these different tasks we want it to do. So the first thing that this task does is it calls the Alpha Advantage API, which is a stock and cryptocurrency API, and it returns the exchange rate, and then it multiplies it, and then it converts the number into a Solidity understandable number. And then with this ETH transaction, it posts it back on chain for us. So you're exactly correct. When we choose the job, when we choose a job from a node, we're choosing from its itinerary, basically. These are all the jobs we can do. Most of them have kind of this generic one where it's just an HTTP GET, which is the type of job we're going to be pulling from, where we actually will send it the parameters. We say, hey, we want you to make an HTTP GET call to this API. And you'll see that in our code, in the Truffle code. So really fantastic question. And that's exactly right. So we choose the independent node. We choose the job or service from that node. And that's how we're going to get the data. And this is exactly what Price Feeds does, actually. It just goes one step further. And when you guys go production, this is what you should do too, is you grab data through a network of these nodes. So we can go down to these new nodes. We can hit view all nodes, and you grab from a network. You grab as many nodes as you like, or as few nodes as you like. And there's a ton of nodes, right? And then each one of them has their collection of jobs here. So really fantastic question. If you have zero coding experience, do you recommend Solidity or use some like JavaScript and template external adapter with Chainlink? It depends on what you want to do. If you want to build services, JavaScript, but if you want to build smart contracts, you're going to need Solidity. Chainlink has a plugin in Remix, as far as I remember. I will have to look at that. Can we check the code? It's absolutely, everything is open source. Great question. For the node and jobs it provides, yep, it's all open source. Yep. Anyone can be an Oracle, correct? Yep. Anyone can be an Oracle. Good question about the reputation, Jeremy. Yes. So everything you do gets posted on chain. And so we're seeing more and more analytics platforms come out. One of the most popular ones is, I'll type it in the chat, reputation.link. If you guys want to check it out, I have a couple minutes left here and I want to finish going through this demo. Check out reputation.link. They do a great job of aggregating. Would it be relevant to use Chainlink for IoT? Yes, absolutely, Benjamin. For aggregating reputation, exactly as you just said. So definitely check out reputation.link, and you can compare oracles to one another. So that's a great question. Benjamin, I kind of breezed by your question, but that is a awesome question. Yes, absolutely. If you go check out the Chainlink hackathon, hack.chain.link, a number of the projects used like hardware integrations. So we saw someone use an integration with Chainlink with a vending machine. We saw somebody do an integration with like a library card scanner. So that's not quite Internet of Things, but you can imagine, taking those hardware devices, adding, the Internet of Things piece to it. And absolutely. And I'm really excited for when those use cases start coming out. She said I can go over a little bit, so that's good because I'm definitely going to go over a little bit. So back in the code here. So we're going to make this API call to a Chainlink node, and we're going to return the data on chain through this fulfill function. So I'm just going to kind of quickly go through this. Truffle compile. So we're going to compile our contracts here. And so I did, you're going to need two things for working with this. You're going to need mnemonic. You're going to need to export mnemonic equals, whatever your mnemonic is, like Apple. This is your seed phrase in MetaMask, for example. And this needs to be an environment variable. And then you're also going to need to export your RPC URL, which is what you're going to get from like Infura. And this is going to be like www.infura.io/Coven, blah, 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 blah. You're going to need to export both of those. They're going to need to be environment variables. If you don't want them to be environment variables, you can also just hard code them in the Truffle config. I'm going to rush here because I know I'm definitely over, but she said I could go over, so it's fine. So you're going to need those. That's how it's going to interact. So I'm working with my my Coven MetaMask account. So we're going to deploy these contracts to the Coven network. So now we're going to do truffle migrate -- network live. This is actually what's going to deploy our contracts. And if you can see here, we're actually deploying right now. You know, we can see the migrations happening here. Hopefully you guys can see that. Is that big enough for you guys? It looks like it's big enough for you guys. Hopefully you guys can see that. But we're going to deploy. You can also use npm run migrate live. I think that's what it tells you to do when you download it. But you know, I've been around the block, I guess. So this is deploying our contract to Coven, and we can even check out Etherscan. No, I'm 1 minute over already. We can even check out Etherscan. We're doing awesome stuff here. Etherscan. So we're quickly check out Etherscan. And this is the contract that we just deployed. So go back to here. Cool. Cool. So we just deployed it here, and we can see all the details. This is, you know, this is the contract address. This is the transaction hash. The migrations contract, don't really worry about that. This is used for like keeping tabs on where all the migrations are. So, so cool. So this migrations happened through this migration.js. This is kind of what defines how it gets migrated. This script has a bunch of really nice things to make it a little bit more friendly cross-change. But you can definitely check out some other examples that are a little bit simpler if this is a little bit confusing. But yeah, this is the script that we basically just ran. So now that we have it, we have this contract on chain. What we want to do is we want to be able to make this API call and get the data, because all this smart contract is doing is just making an API call. So if we have these 3 scripts here where we're going to request and read data. If we do this right now, Truffle Exec scripts read contract network Coven, we should get nothing back basically, or it should error. That works too. Oops, it's network live. Sorry. We should get nothing back because we haven't requested any data. So I think we should get 0. We should get 0, exactly. So all our contract is doing here is just going, make an API call, asking the node, give me the data back. So it's 0 right now, which is exactly what we want. And then you can check this on chain as well. So the first thing that we're going to need to do is we're actually going to need to fund this contract that we just made. So we're going to do Truffle Exec, and exec is how you run scripts with Truffle. Truffle Exec scripts, fund contract.js, network live. And again, this is connected to my MetaMask account. So I'm actually this script is sending testnet ETH from my MetaMask account. Again, that comes from my mnemonic. So it's sending it's sending link to this contract, and we can check to see if this was successful. Scan Coven. The last one I sent you, I showed you guys, wasn't a valid address, but anyways. So here we are here. So we sent some link, and we can see the transaction right here. We sent 3 link, and we can see in our token balance here, this contract now has 3 links. So now the contract is funded. Now we can make our API call. Now we can work with the oracles here. So let's go back. Cool. And now we're going to do Truffle Exec scripts, data, network live. So now we're going to do this part of ours. Now we're going to call this smart contract. So we're calling this create request to our script request data has a bunch of parameters that fill the parameters of this create request to method in our smart contract. So the script is actually populating all these. It's picking the oracle, the job ID, payment, URL, path, everything. We're calling from this API right here, which returns the price of ETH in USD. And We're calling it with this build Chainlink, or excuse me, we're building the request with this build Chainlink request. We're adding the URL because, again, this was one of those generic jobs that we saw where we could give it the parameters. We're giving a path to walk down the JSON path because, again, we only want to return exactly what we want. And then we have this this times because, again, it doesn't work great with Solidity. We send the Chainlink request, and then the Chainlink Oracle is actually the one that then will respond, and the Chainlink Oracle will call this fulfill function in your smart contract. So it'll call this fulfill function, this record Chainlink fulfillment, make sure it's the Oracle that you can only call this, and it's going to set our data variable up here, our public data variable, to the data that was returned based off of our ask. So if we did everything right, now if we run that read contract, we should get a number back. Hopefully we gave it enough time, and it looks like we did. So we got 464.78, and we know because we did this multiply feature that it's actually 464.78, and we just returned this higher value. So this was an example of getting data with an API call. This is really kind of like the basic, the super basic functionality here. Let me show you. I just want to show you guys one thing real quick, and then I'll take some more questions. So you guys can see that, right? Okay, cool. So that's what powers this price feeds. That's what powers a lot of the rest of the Chainlink ecosystem. However, getting pricing data is actually even easier. So you don't have those. So this is an example of like a smart contract getting pricing data. You don't have this fulfill, get asynchronality. You actually just call this get latest price, and you check the price of you just check the answer that was already gotten from that nice visualization that we had, right? So they already posted it on chain. All we're doing is checking what they already posted, and this is literally the easiest, most reliable, most secure way to get this pricing data. And there's a ton of pricing data. You can check out all the contract addresses for Ethereum here. If you want to work with Binance Smart Chain or Matic, it's there as well. But yeah, the docs have literally everything that you're going to need to know. And again, community is there for you if you want to learn more. So with that, I will jump into some questions. I will stop sharing here. I hope that was helpful for you guys. The Truffle demo is definitely a fantastic tool to work with. Truffle is a great tool, and they also give me chocolate, so that's really cool. Anyways, so let me jump into some of these questions here. Would it be relevant to use Chainlink for IT data? Yes, yeah, we already talked about that. Absolutely. This demo is really cool. Absolutely. Thank you for being here. I hope that you joined, you got something out of this, and you can go build some awesome Chainlink smart contracts. Even if it's just, running through this demo, if you run through this demo and you're able to get data back, or, you follow along the docs, tweet at us, like shout out, say, hi, I'm really happy about this thing that I did. In our Discord, we have a look what we built channel. So if you're really proud of something, pop in there, say, hey, I'm just really excited to be here. Because it's this wonderful thing to be a smart contract developer, and even better, even more to be a Chainlink developer, because that means you're getting, that you're going to be working with this decentralized data as opposed to some centralized entity. Can we get the repo for this? Yeah, absolutely. So you can do. So if you have Truffle installed, you can actually just call that command. Where did I go? Okay. You can call that command, and it'll actually download this whole repo. Otherwise, if you look up smart contract kit box, oh, here it is right here. I'm gonna give it to you right now, actually. It's right here. And it's set up right now for Ropsten. I changed the addresses to Coven. You can check the documentations to learn how to kind of flip the addresses, but good question. If you need currency data that is persistent, so one could check the timestamp against the exchange rate for any transaction. If you need, could you ask that question again? If you need currency data that is persisted, so one could check the timestamp against the exchange rate for any transaction. I think I persisted in time. Yeah, so you can check the, actually, let me even just share screen again. I think I understand what you're asking for here. So when you call this function, this get latest price function, it returns all this round data, right? So it returns more than just the actual price. So it returns like the timestamp. So if you're looking for a timestamp that's, if you say, hey, you know, I only want data that's less than, you know, 5 minutes stale, you just check the timestamp right there, and that's how you would do it. So that's a good question. Like indexed at intervals. Persistent in time, like indexed at intervals. I'm not sure I follow. Yeah. So there's also this get historical price data. Maybe that's what you're looking for, where you can go back round IDs and you get the timestamp in the round IDs. I think maybe that's what you're looking for. But yeah, that might be what you're looking for. What are the requirements to be a node Oracle? I think we've spoken before too. Hey, how's it going? Nice to see you back here. You can check out the docs. You know, again, the docs are where the docs and the Discord are really where we can live. You can find literally everything here. You know, you don't need a whole lot. Anybody can spin up a node. Anybody can spin up an Oracle. You can have a small box, you know, a 5-10 gigabyte VM, maybe a processor or two, you know, maybe 4-8 gigs of RAM. If you're going to run a production node, you're going to want to beef that up a little bit and have backups and such. But to, you know, just run a Chainlink node, you can absolutely do it with really small infrastructure costs. What's the link to the documentation on screen? I swapped the documentation on screen, so let me send you this one. So that's to get the latest price. The historical price one is right underneath that. Oh, so nice. Somebody else already. Oh, cool. Awesome. Both of you guys did that. Cool. Thank you so much for helping out there. So with that, that is I'm super over time, like 13 minutes over time. But I hope you guys got a lot out of that. This is, you know, like I said, this is really, really powerful stuff here. Truffle and Chainlink make it really, really easy, really nice to build, test, deploy these smart contracts. So I hope to see you guys' project. I hope to see what everybody builds. Really excited to be here. Really excited to see what everybody builds. And yeah, if you have any other questions, feel free to reach out and we'll talk to you then.